All right, we're going to talk about spinal cord cross-section and really reflexes more than anything. So hopefully you've reviewed a spinal cord cross-section. So this is my version of a spinal cord cross-section. Remember, we've got that gray matter in the middle. We have the gray commissure, which is connecting the two sides. And with the gray matter, we have an anterior horn kind of in the front. It's usually a little more rounded. The posterior horn typically extends all the way to the back edge of the spinal cord cross-section, and it usually appears to be a little more pointed than we find in the anterior. That's kind of one way that we can differentiate between the two. Now, coming off of those horns then, we would have those rootlets that we see on the cadaver picture of the spinal cord cross-section, or we see in a typical cross-section. But the rootlets are those bundles of axons that are either going out of the spinal cord or in to the spinal cord. And hopefully we remember that the posterior rootlets are carrying sensory information into the spinal cord. Anterior rootlets are carrying motor information out of the spinal cord. And then hopefully we remember there's going to be that swelling, that ganglion, that dorsal root ganglion that we've talked about on the posterior section. So these are going to be that cluster of cell bodies for those sensory axons, those sensory nerves coming in. So both the motor and sensory information are ultimately going to merge and form what we call the mixed spinal nerve. So remember, a mixed nerve we talked about in chapter 11, but that's carrying motor and sensory information within the same nerve bundle. So it's like a two-way street. We've got traffic going both directions. So, in a reflex, first of all, what is a reflex? Well, a reflex is a protective mechanism. It's an automatic motor response to some sort of threatening stimulus. So maybe you put your hand on a hot stove. Maybe you see a flash of something coming at you and you get a visual reflex. Maybe you hear a loud noise and it causes you to jump, some kind of an auditory reflex. But we think of it as a protective mechanism, a motor response to some kind of sensory input. So the components, sensory input, we have to have a receptor. Well, who are the receptors in the body? You know, it could be a temperature receptor, a touch receptor, your ears, your eyes, whatever it may be. We have a sensory nerve signal. In this case, we're showing it coming into the spinal cord. In the spinal cord, we may have an interneuron, a connector. Remember, interneurons are neither motor or sensory. They connect motor and sensory. And then coming out the anterior horn, we're going to have a motor pathway that we see here in blue that's going to be going out to skeletal muscle, causing some sort of a physical response. We turn, we quickly pull our hand away, whatever the case is. So we're going to look at reflexes in a couple of different ways. First thing that we want to mention is that we are talking about spinal cord reflexes. We are talking about information coming in a sensory path from the body, and we are going to stimulate some sort of motor output, skeletal muscle contraction, also out in the body. But the reflex is being turned around at the spinal cord level. So what do we mean by that? Well, put your hand on a hot stove. You've got a sensory signal that comes in. What we mean by a spinal cord reflex is it's the spinal cord that's going to create the ability for us to move away, to protect ourselves. If we had to wait for that information to travel all the way up to the brain, integrate, interpret, ooh, that's hot, I better pull my hand away, and then send a motor signal back down, Imagine what your hand would look like by the time you actually pulled it off of the stove. It's going to take too long. So, we have a protective mechanism that's going to occur here at the spinal cord. How do we know it occurs at the spinal cord? Well, when that sensory information comes into the posterior horn, two things are going to happen. Number one, I'm going to jump on that interneuron. I'm going to jump on that connection to the anterior horn so that I initiate a motor output. But at the same time, I'm also going to jump on one of those ascending tracks. I'm going to send the information up to the brain. Why? We have to integrate. We have to interpret what's going on. But how do we know it's occurring at the spinal cord? Have you ever been in your kitchen? Or maybe you've got a laundry room with an ironing board set up and you've got an iron sitting on it, but you put your hand on the stove or you bump into the iron and you quickly pull your hand away, only to then realize it wasn't on. There was no temperature, there was no threat there. If you were fully integrating and interpreting that information, you would know it wasn't on and you wouldn't have pulled your hand away. But you do, you reflexively pull away. We're trained that, yeah, stove's hot, the iron's hot, we're going to get burned, that's going to hurt. And so when we do accidentally touch that thing, we do get that quick withdrawal before we actually even have the ability to interpret what happened, that, oh, it's not on. So again, protective mechanism being turned on down here at the spinal cord level. Now, there's a group of reflexes that we want to specifically talk about, and those are what we refer to as somatic reflexes. So, if you remember, somatic, if we refer to somatic sensory, that's information that we're getting from skin, information from muscles, tendons, or our joint capsules. All of that is somatic sensory, somatic input. Remember, somatic motor is skeletal muscle, voluntary muscle. So when we talk about a somatic reflex, what we're saying is sensory information coming in from a somatic source, skin, muscle, tendon, joint, creating a reflex that is going to activate skeletal muscle. So, some examples of that. The first one would be that flexor withdrawal reflex. You're going to flex to withdraw from something. This is hand on the hot stove. If I put my right hand on the hot stove, I'm going to send a signal in. I'm going to connect to a motor output, and I'm going to withdraw. I'm going to flex my right hand. So, hand on the hot stove, you put your hand on something sharp and you pull away from it. That is a flexor withdrawal response. If somebody were to walk up to you and they were going to pretend like they were going to punch you in your stomach, you would flex, contract your abdominal muscles, and try to withdraw from that stimulus. We refer to this as an ipsilateral response. Ipsilateral, same side. So if I put my right hand on the stove, I pull my right hand away. Ipsilateral, same. The second reflex that we will get is if we look at what we call a tendon stretch response. This would be what happens when you go to the doctor and he taps you on the knee with that reflex hammer. So you're sitting in the doctor's office, you're sitting on the table, and they take that reflex hammer and let's say they hit you in that patellar tendon right below your kneecap. You're going to send a signal in, and that patellar tendon is actually joined to the motor output of its muscle, the quadricep group. And so what happens when you're sitting on the table and they tap your knee? You kick your leg straight. The agonist muscle, the muscle of the tendon, contracts. The antagonistic muscle relaxes. And so in this case, the hamstring muscles, the antagonistic group, when you contract your quadricep to straighten your knee, that hamstring group is going to relax to allow that movement to occur. So I hit the tendon, the agonistic muscle, the same muscle of the tendon, fires. The stretch reflex we could do with the bicep muscle, we could do it with the triceps, we can actually hit brachioradialis, the Achilles tendon. Any of these superficial tendons are going to fire when we stimulate a stretch response in their tendons. It's a protective mechanism for the tendon. When the tendon thinks it's being lengthened, it's going to try to shorten. That's a superficial response because those tendons are right underneath the surface of the skin. We also have what is referred to as a deep tendon reflex. And so in the deep tendon, if I were to stimulate a deep tendon in the quadricep, it would actually do the opposite. It would contract the hamstrings. It would contract the opposite muscle group. The same muscle group would relax. And these deep tendon reflexes are thought to be highly involved in some of our movement patterns. If we think of things that are kind of reciprocal, walking, running, skipping, we have motor programs that a muscle group is on, and then it's off, and then it's on, and then it's off. And these deep tendon reflexes are involved in those movement patterns because of the way that the antagonistic muscle is caused to fire when its opposite muscle group is stretched. There's a lot of research out there on cats looking at movement pattern generators in animals and where our motor programs are actually coming from. There are studies out there where you'll take a cat that's paralyzed, and if you lower it onto a treadmill, it will actually walk. When you pull it off, it's still paralyzed. The idea being that a lot of these movement pattern generators for a lot of our gross movements are actually being generated more at the spinal cord level than the brain level. The spinal cord is much more involved in movement than we probably give it credit for. And so a lot of that neurological research is actually focused on these movement pattern generators and how we move. So we've got to give the spinal cord a little more credit than just being a relay center for information. The last reflex that we'll kind of take a look at, sometimes we do have what we refer to as contralateral reflexes. Contralateral would be opposite side. So if I stimulate something on the left side of the body, in a contralateral reflex, I'll get a response on the right side of the body. And the reason for that is this gray commissure. The fact that I can connect a sensory posterior horn on one side to the anterior motor horn on the opposite side. So we refer to this one as a crossed extensor reflex. Imagine you're walking along barefoot, and as you step with your left foot, you step on a piece of glass. What are you going to do to your left foot? You're going to pick it up. Your protective mechanism is to flex. However, if I'm walking along and I'm standing on my left foot and I want to pick my left foot up, what do I need to do to the right foot? I better put it down. So as I'm flexing on one side, I'm extending on the opposite side. So my piece of glass on the left foot is causing a flexor response on the same side. I pull that foot up, but at the same time, I'm extending, stimulating my extensor muscles on the opposite side of the body, that contralateral reflex. And again, it's a protective mechanism so we don't fall down. This is important because what we're describing is the way to stimulate the left side of the body to create a response on the opposite side of the body. So think about somebody that's had a stroke and they've got paralysis of the right side. Well, we're just looking for a window. How can we get them to activate muscles on the right? Well, I can use reflexive activity on the left. So I've got somebody that cannot fire muscles on the right side of the body. I can tell them, okay, I'm going to take your leg, I'm going to push it way up like this, and when I say go, I want you to extend. I want you to push your right leg. And they say, well, I can't do that. I don't have any control over it. Trust me. When I say go, you push with your right leg. And so I'm going to have somebody else that's going to take something sharp and I'm going to stroke maybe the bottom of their foot. I'm going to cause a reflex on the left side that's going to cross over to the right. So when I say go, you push. Well, when I say go, we stroke the foot, and what happens? We get a reflexive response. They extend. And what do they see? Wow, I did it. I wanted to try to straighten my leg, and I just straightened my leg. I just got those muscles to fire. And all we're looking for is a window, a way into the nervous system to connect what the brain is trying to do with what the muscle is actually doing. So, are we tricking the nervous system? Yes, we are. But in doing so, we're reestablishing pathways that we'll see in neurological rehabilitation to reestablish normal motor function. So those are some of the reflexes that we see, that reflex arc. And again, that will supplement some of this material that we see in chapter 13 with the peripheral nervous system.